Welcome to C# Step by Step. This week we're going to build a pizza ordering system using just what we've learned in the previous lessons. Now just as a quick heads up, this project is based on a university course I taught a while back. I didn't design the course, I didn't design the assignment, but I did create this walkthrough for it, so I hope you enjoy it and learn a lot. Keep in mind that if you were building a pizza ordering system in real life, there are some other things you would want to do to ensure that the system was safe and handled rogue inputs and things like that. However, we want to keep things focused on just the material we've learned so far. So in this video, we're going to do a walkthrough of assignment 3, the pizza ordering assignment. So looking at the instructions, we are going to build the logic to calculate the price of a pizza for a new shop that just opened. It will ask for inputs and then use those inputs to determine the final cost. And we can either buy pizza by the slice from pre-made pizzas, or we can order entire pizzas and determine how many toppings we want. So here is our logic flow. First, we ask if the customer wants to buy an entire pizza or by the slice. We will enter 1 or 2. Then for an entire pizza, ask whether it's going to be medium or large. And we have the prices for that. And then ask for the number of toppings. And if we're asking for by the slice, then we're going to just charge $2 per slice, and the user will not be asked for the number of toppings. And we have some example inputs here and what the expected output should be. It also mentions that we should print the output as shown in the example. So we should print what type of pizza, how many toppings, and the price, or number of slices, and then the amount for the total. So let's think through this program. And again, I always like to start out, if I'm doing a complicated program, thinking through the steps and outlining that using comments, because that makes the program easier to organize. So first we're going to determine type of order, and that'll be 1 for whole pizza, 2 for slices. And then we're going to ask for, if we have a whole pizza, then we're going to ask for the pizza size. And that can either be M or L. And then we have some prices there. So we'll just think about that for later. And the other thing we want to ask for here, and we'll just hit that so we know that goes together, ask for number of toppings. And then finally, down here, otherwise, ask for number of slices. So this is the logic flow. I could have copied and pasted this, but I just wanted to type it out in a more simplified form. So step 1, do this. Step 2, if we have a whole pizza, is this. Otherwise, step 2 is this. And then finally, we're going to print the output. Now, there are a bunch of ways we could do the output, but for now, I'll just put print the output. So there are a couple of ways we could do type of order. So it's using numbers here, but we can just treat those numbers as strings because we don't care about their numeric value. We just care about their symbolic value. The way I'm going to do this is I'm going to say enter the type of order. And then we'll say I'm going to insert /t. This is a tab character, so it's an invisible character that's going to cause the output to shift over exactly 1 tab mark. And so I'm going to say 1 entire pizza, 1, or pizza slice. Put this in parentheses, slices. And maybe we'll do it like this. We'll say 2, 1, that, so the user knows what to enter. Put a semicolon here. Let's run that. See if that prints out how we expect. So enter the type of order, 1 entire pizza, 2 pizza slices. And then let's give them a little prompt line here. Let's put this with maybe an arrow, space, like that. And then we will ask for string pizza type equals read line. Now there is a slight problem with this that I'll show you here, but at first we'll put a breakpoint so we can see the problem. So we'll run this, and we can see that we have our order and our prompt, but we notice that our input cursor is on the next line. And the reason for that is because we use write line instead of write. Write line puts an implicit new line at the end, so basically like pressing enter or return. And so instead of write line, what I'm going to do here is just change that to say write. And so it's just going to output this to the console without a new line. And so when the read line starts, the cursor, see here, will be right there, right after my prompt mark. So just a nice visual indicator of where the person should enter the pizza type. Now, the next thing I want to know is if I have a whole pizza or not. So this is fairly easy to do. You could convert this to an integer, but we don't have to. So I can just say if pizza type equals so I can just say, since it's a string, I can say if pizza type equals 1, then do this. And let's move my comments into here. Otherwise, okay, so I have this section. So let's write this out. If pizza type, all right, so now I've got my pizza type as a string. Don't need to convert that to a number because we don't care about its value, like its numeric value. We just care about whether it's a 1 or a 2. And we can check that as a string as well. So now let's go ahead and do my if statement here. So if pizza type is equal to 1, then we are going to go through this logic. Otherwise, we will go through this logic. So let's test this to make sure this works the way I expect. And we'll just say whole pizza. So again, just testing little bits of code, one piece at a time, to make sure that each piece works. So I'll run that. If I type a 1, I get whole pizza. If I rerun that, type a 2, I get slices, just as I expect. So these little statements, these are called debugger statements. Some people call them tracer bullets. It's just a way to print out little statements in different parts of the program to test control flow and to test where things are working or going wrong. So just temporary debug log statements, print statements that will help you to just make sure the program's working as you expect. All right, now let's go ahead and complete this logic. If we have a whole pizza, we want to ask for the pizza size, and then we want to ask for the number of toppings. So first, let's ask for the pizza size, and we're going to do this using the same pattern that we did up here. So we'll say write line, enter the pizza size, and once again, I'm going to use that invisible tab character just to make things line up nice. So medium pizza. Large pizza. Then I'm going to use that same prompt trick that we used here. Say pizza size equals read line. So the next step is to ask for the number of toppings. Enter the number of toppings. And we don't have any options for this. So we'll just put our little prompt there. And read line again. But this time we do want to do a conversion. So we'll say topping count equals convert to int 32 toppings, because in this case we do care about the numeric value because we have to do some math with it later on. Now let's go and test this to make sure that this works. So we got our entire pizza. Pizza size is going to be medium. Number of toppings will be 2. And that all seems to work out okay. Let's go ahead and do this prompt down here. Enter the number of slices and read that line. Oh, we need to do our little prompt here. Keep that up for consistency. And then once again, we do care about the number value here. So we'll convert that to an integer. Okay, now we have all of our inputs here. We're going to test just to make sure our pizza slices input works. Seems to work okay. And now we come to the stage where we are going to print the output. Now, in order to do this, there are a bunch of ways you could structure this, but I'm going to structure it a specific way because I want to illustrate a couple of principles. So first of all, to do the output, I need to know what they ordered, whether medium pizza, large pizza, number of toppings, or number of slices, and then I need to know the total. So here's a good rule of thumb. This block of code tells me this information. It allows me, it only runs if we are getting whole pizzas and I get the number of toppings. This block of code is where I'm collecting all of the data for the number of slices. But down here, outside both of those blocks, is where I need to print out what they ordered and how much it was. So I need 2 pieces of information here, what the order was and how much the order cost. Since that information can be determined inside this block or inside this block, in order to access it here, my variables have to be created outside of these blocks. If I create a variable here, like this, for example, and I do all my calculations for how much they ordered inside this block, then I will not be able to print it out here because that variable only lives, its scope is within these 2 curly braces. So instead, what I'm going to do is I'm going to create 2 variables outside of this. And so that will be in my function scope inside these curly braces. So it'll be available to anything inside of those braces. So I need 2 variables here. Order description, which is going to be a string. And right now I'll just set it to be an empty string. And then the final thing we need is a place to hold the total. So I'm going to use a float for that. You could use a double, you could use a decimal. I like floats. So to put an F there to indicate that that's a float. And so our total initializes to 0. Our description initializes to an empty string. Okay, so first we need to calculate the order description string or generate that. And so this is our string, medium pizza with 2 toppings, large pizza with 3 toppings. So we need the size of the pizza and the number of toppings. So first we could say if pizza size equals m, okay, then our order description is going to be medium pizza. We'll just leave it like that for a second. Otherwise, order description is going to be equal to large pizza. Now, we've got a couple of problems here. First of all, we need the number of toppings in there. Second, we have a problem. What if the user types a lowercase m instead? So there are so many ways to deal with this. I'm going to show you 2. One is we can say if pizza size to lower is equal to lowercase m. So what this does, if they type an uppercase m, it'll convert it to lowercase before it does the comparison. If they type a lowercase m, it's already lowercase, and then they'll do the comparison. Either way, it'll match lowercase m. The other thing you can do here is you can say pizza size dot equals m, and you can change the comparison type to be ignore case, and either where we care about the current culture or we don't. So we're going to do invariant culture, ignore case. So when we do that, it'll have essentially the same result. We're going to say, don't worry about if it's uppercase or lowercase, just compare it to m. Now, most people don't do that. Most people are going to say 2 lower equals lowercase m. Now, this can be problematic to do it this way if you're dealing with languages other than English, but in our case, our entire target market is English speakers. So we're just going to do it the simple way. All right, so we have that medium pizza. Now we need the number of toppings. So what we'll do to get that is we'll change these to be format strings, and then we can add with topping count toppings. We'll just do that same thing in both spots. So now, depending on what they order, we'll generate this order description. So we have this. Now we also need the order total. So our order total is going to be, if they ordered a medium pizza, then it's going to be 7 plus topping count times 1. You could just say plus topping count, because if there are 5 toppings, it's $5. But I'm going to leave it like this because what we're going to do up here is we're going to create a const int topping cost equals, we'll make it a float rather. And then we will replace this with topping cost. So what we will always want to avoid in code is what are called magic numbers. Numbers that have no name, that just make our code work no matter what. We've talked about using consts before. And so this makes it so if I ever need to change the cost of what my pizza toppings are, then I can just change it here and it will affect the code everywhere. So I'm going to do the same thing with medium pizza cost and large pizza cost. Then we'll go ahead, while we're here, we'll go ahead and do slice cost. So we have all of those constants defined up there. So instead of 7, because someone comes along, they're like, why is there a 7 here? What does this represent? Now, in this case, it's a little obvious, but in more complicated programs, having a bunch of random numbers, which again, we call magic numbers that just magically make the code work, is considered bad practice. So we want to make sure we have semantically correct calculations. And so now, how do we get to the order total? Well, we take the medium pizza cost, and then we add however many toppings they have multiplied by the topping cost. And it's obvious what's happening here. And we'll do the exact same thing down here. I'm just going to copy this line of code, but instead of medium pizza cost, we're going to do large pizza cost. So then down here, in the case of number of slices, we're going to do something very similar. Order description is going to be, and we're going to use a format string here, and we're going to say slice count slices of pizza. And then our order total is going to be equal to slice count times slice cost, because we have that defined again up here at the top. So now to print the output, we can just say right line, and what we're going to print here is our order description is order total formatted as currency. And so let's go ahead and run that. And again, the C gives us the localized currency format. Let's run through this with our test cases. We do 1, M2, medium pizza with 2 toppings is $9. Let's do the second test case. You should always do all the test cases. Large 3, large pizza with 3 toppings is $13. 2 slices of pizza is $4. And 4 slices of pizza is $8. So that all checks out. Now, there are a bunch of other ways we could have written this program, but just to review a couple of key points, we have our amounts declared as constants at the top with names that make it obvious what they are. which also makes it easy to later change things. So if I want to change the topping cost, if toppings suddenly go up to $2, I can just modify that here. If this calculation was used in a bunch of places in a very large program, that makes it a lot easier. I also have this prompt line using right instead of right line so that the cursor shows up on the same line as the prompt. And most of this other stuff is review from previous weeks. We do a case-insensitive comparison here, just in case the user types in a lowercase m instead of an uppercase m. And then we declared variables outside of these blocks so that we could use them inside of both and then, again, refer to their values later on. So those are the key points that I want to make sure everybody is clear on. If you have any questions, be sure to ask on Slack or through email. That wraps up today's lesson. Tune in next time and don't forget to like and subscribe.